Baldor uses world-class manufacturing to build AC cast iron frame motors at its Athens, Georgia plant. Available motors range from 40 to 1,500 horsepower. Construction begins as raw bar stock is manufactured into a finished shaft. The bar stock is cut to length and center hole drilled. The individual pieces are turned on a CNC lathe to the outer dimensions required for a specific motor design. The automated process is computer controlled for precise, repeatable part manufacturing. Finished shafts are grouped by design for use later in the manufacturing cycle. Unmachined frame castings are supplied to Baldor with a primer paint coat already applied. Athens machines its smaller, higher volume frames on a continuous transfer line process. Multiple machining operations are done on a continuous basis, increasing productivity. All frames are washed after machining to remove any metal shavings that could damage the insides of a motor. Larger cast iron frames are machined in a state-of-the-art automated machining center. This fully automated machine efficiently completes all of the precision machining steps required per the motor's design. The cleaned, finished frame is ready to be moved to assembly. Cast iron end plates are supplied to Baldor already primed and ready for precision machining. Baldor uses specialized silicone steel for its laminations that reduce electrical losses and increase motor efficiency. The coil spools are unwound into a press that straightens the steel to the necessary flatness for stamping. Finished rotor and stator laminations are punched from the same piece of steel. All waste metal is recycled. Heat treatment of the finished stamped laminations is required to relieve stress in the steel. This process improves the electrical and mechanical performance of the parts. Computerized quality control inspections confirm that exact design tolerances are being met during the manufacturing process. Stator laminations are stacked to the required design height and loaded into an automatic welding machine. The welder compresses the stack uniformly to minimize distortion while welding it together into one piece. The lamination stack begins the stator winding process by having slot liners inserted. These insulation liners will protect the copper wire coils from being damaged by the lamination steel. Automated coil winding equipment is used to form coil groups. Finished coil groups are transferred to an automatic insertion machine that uses precision alignment to carefully insert the coils into the lined stator slots. Phase paper insulation is inserted in between coil layers on both ends of the winding. Proper insulation placement is important to ensure the long life of a motor winding. Coils are connected per the electrical design requirements. A careful brazing process makes the connection secure. Lacing is added to increase the mechanical strength of the winding. This will prevent vibration and movement of the coils during motor starting and operation. All finished stator coils undergo a computer-automated electrical test before leaving the winding area. This ensures no components were damaged during assembly. The coils were connected as the design required, and that the performance of the stator coil meets acceptable design parameters for the part. Varnish is applied to the stator, coating the coils and other insulation materials. When dry, the stator becomes a solid unit, preventing coil vibration and movement. Stock motor designs use a dip and bake varnish process. Athens also offers a vacuum pressure impregnation process on custom designs. The stator is now ready for insertion into the motor frame. Smaller size motors have the stator pressed into the frame. During this process, the motor leads are carefully fed through the outlet hole in the frame. Larger frame designs are assembled by heating the frame so that it momentarily expands just enough to allow the stator to drop in. Once inserted, the stator is welded to the frame to prevent movement. Rotor laminations are stacked on a casting pin that controls skew angle and concentricity of the lamination stack. The laminations are pressed to prevent distortion during casting that could damage the coating on the steel. The casting machine precisely controls the injection of the molten aluminum from the bottom up into the rotor stack, eliminating porosity in the casting. Each cast rotor is final inspected before it is given a mark of approval by the operator. The keyed shaft is pressed into the cast rotor to create a complete rotating shaft assembly. On NEMA 440 frames and larger, the shaft is permanently welded to the rotor to prevent any movement. After assembly, the shaft is checked for proper runout before it can move on to final machining. The shaft is now ready for machining to its final dimensions. Computer-controlled machining is used to achieve the proper air gap tolerance. The shaft is dynamically balanced to exact specifications. This improves motor life due to less vibration of the rotating assembly and bearings during motor operation. Severe duty motors get an epoxy protective rotor coating for harsh environments. Bearings are expanded by induction heating and slid onto the motor shaft. They are temporarily wrapped during final assembly to prevent contamination. All parts needed for final assembly are collected together on trays and delivered to the assembly station, where they are carefully assembled into the completed motor. Impro Seal bearing isolators are installed as standard on both ends of IEEE 841 motors used in petroleum processing applications. Mounting flanges on large frames are machined again after final assembly to ensure the flange face is true to the motor shaft. Each motor is given a routine test after final assembly to ensure the assembled motor will perform to design requirements. Custom testing is also available in the Athens Test Lab, where witnessed and unwitnessed full-load dynamometer testing is one of many testing services available on request. Motors are painted to their specification with epoxy or lacquer finish. Shipping pallets are built to size, providing sturdy support and protection of stock and custom motors during shipment. All motors are securely fastened to the pallet. Nameplates and labels are matched to the order and mounted on the motor. Protective plastic covers the completed motor and shipping labels are attached. Completed motors are shipped daily to customers and Baldor distribution centers. Baldor, the industrial choice.